Now we learn about the functional interface. Okay, let us revise the previous lecture concepts. What we have introduced or do there. We learned the lambda expression and a functional interfaces. Okay, so what are the lambda expression? Why it is used? What is the need of the lambda expression? So just we are going to revise. So the minimum objective of lambda expression is to bring the benefits of the functional programming into the Java. Why lambda expression? Lambda function is just as what is the lambda expression? Okay, so lambda expression or a lambda function is just is an anonymous means nameless function. That means the function does not have the method name, return type, and the access modifiers. Lambda expression is also known as closure or an anonymous function. Then we had seen different rules to write a lambda expression. So lambda expression, lambda methods does not have the access modifier, does not have the return type, does not have the method name. Only the parenthesis is method arguments and the function body. So and between them there is a arrow symbol. So this is a lambda mark. If there is only one statement, then no need of this curly braces. This is optional. If compiler knows the context of to the input parameter, then no need to provide this a type parameter as well. Compiler automatically convert this type, automatically recognize this type. So it is known as type inference in a Java. Automatically type conversion will be happen. So no need to provide implicitly a given type. Even there is no need to provide if there is only a one statement, no need to provide a return statement as well. Compiler automatically knows that it is a return statement, and if it is only the one argument, then we no need to provide the this parenthesis as well. So this is the simplified version to write a lambda expression of a given method. So you people can see this much of lengthy code we can reduce only the three words str before functional programming. We need to write a method, then we need to create the implemented class, means this object, then we need to we need to call this method through that object, then only we are able to reuse this functionality. Understood? But now we are able to, by using a Java 8, we are introducing functional programming into the Java. So we can see there are different rules like lambda expression can have zero or more number of arguments or a parameters. If compiler expects the type based on to the content, then we can uh, remove type as well. If multiple parameters are present, then these parameters are separated by commas. If only one parameter is available and if the compiler can expect the type, then we can remove the type and the parentheses as well. Lambda expression body can contain multiple statements. If more than one statement present, then we have to enclose them with curly braces if one statement is present, and curly braces are the optional. These are already missing. Once we write a lambda expression, we can call that lambda expression just like a method. For this purpose, functional interfaces are required. Then we have also seen what is a lambda expression, by lambda expression. So, why lambda expression? To enable functional programming in a Java. Okay, so if someone is asked why lambda expression is introduced, to enable functional programming in a Java, write more readable, maintainable, and a concisable code into the Java, and to enable parallel programming. What is parallel programming? For because in a Windows or in another operating system there are multiple processors which are working. So to utilize those processors, parallel programming were parallel processing in a Java. Okay, So now we see what is a functional interface. These are the like why lambda expression are used in a Java. So why it is used to enable functional programming, write more readable, maintainable, and a concisable code, and to enable parallel programming in a Java. Another one is a functional interface. So what is a functional interface? The functional interface is if an interface contains only one abstract method. What is that? Only one abstract method. Such type of interfaces are called a functional interface, and that method is called functional method or a single abstract method. So what is a functional interface? An interface contains any number of abstract methods. Okay, before Java 1.8, but from a Java 8 onwards, we can write default methods and a static method as well into the interfaces. But in a functional interface, only one abstract method can be there. Any number of any number of default methods and any number of static methods would be there. But how many of abstract method would be there? Only one abstract method would be there. Like runnable. There are only some before Java 8 there are already some functional interfaces were there, but it was not like declare it is a functional interface. But from Java 8 they were using at the rate functional interface by giving forcefully that it should have only one abstract method. Understood? That I have already showed you onto the that I have already showed you onto the program by a program. Okay, so runnable have only one abstract method, that is run. Comparable have only one abstract method, that is compared to. Action listener, action perform, and a callable is a call method. Inside function interface we can write only one abstract method but any number of default and a static method. So this we have seen. We have also written a program where we have written at the functional interface. It have only one abstract method and there are two or three uh, default methods. Okay, if we have write one more abstract method, so compiler will be giving me as a error like m2. So sorry, m4. If I am writing m4. What is the error this interface it is giving? Functional interface. Interrupt is not a functional interface. If I am just commenting this one, then there is a no error. So this lesson we have already, these things we have already covered onto the previous lesson. Now today's our topic is onto the functional interface with respect to the inheritance. What is today's topic is functional interface with respect to inheritance. Okay, so what are the different rules which we must follow for the with respect to the inheritance? So we should know like what is the inheritance in a Java. Okay, so if an interface extend a functional interface and child interface does not contain any abstract method, then child interface is also a functional interface. What is that? Inheritance property we have we knows that if a parent class sorry if a inheritance if a parent class uh, subclass inherited to the parent class property through a extend keyword. So inheritance is also happening onto the interfaces. One interface can extend another interfaces. Inheritance can be happen to a class to class or interface to interfaces. Okay, one interface with respect to the class we use a implements keyword. So if an inheritance. Okay, so if an interface if an interface extends functional interface functional interface and child interface does not contain any abstract method, then child interface is also functional interface. Okay, means if an interface is there and it is extend another interface which is a functional interface and a child interface does not have any method, so it is inherited to the functional interface. So superclass method can be used by a subclass subinterface method. So by default property inheritance property would be applied and child interface would become a functional interface. Okay. Example, if we see, I remove this thing. So this is my one interface, it is in here, and I am taking another interface. Interface B extends interrupt. Okay. So by default, this interface is become a functional interface. Okay. So if we have write in here as a functional interface, at the functional interface. So no any exception it is showing in here, right? But if we have writing any one method, like one abstract method I am writing public abstract return void return type void m4. Okay. So this is giving error if you see invalid functional interface annotation B is not a valid functional interface because this interface is extending to this interface which is already a functional interface. So by default parent class property parent class method is inherited into the subclass methods, sorry, subclass properties. So it is visible to there. So this method it is already implemented is introduced in here. If we are if we defining again method, so there would be the two methods. So it is not, but we can give a default method in place of public. We can give default and we can give body. Okay, what is the error in here? Illegal combination of all the it is a functional interface. Understood? So this is the property of this one. Another thing, in the child interface, we can define exactly same parent interface abstract method. We can say if we have defining another method, it is giving error. But if we have defining same abstract method, which are defining in here, so Here is no error. Either we are not defining or it will be defining the same parent class method. So it is a method, it is a runtime polymorphism, I can say. It's not a runtime polymorphism, means it is a polymorphism. So yeah, means it is like um, method overriding. We in a parent class and we are defining in a method, same method on the so polymorphism, it is the one concept of a method overriding, which method is introduced to the current object stored into the reference variable. So that is concept of a oops. In the child interfaces, we can define any new abstract method. Otherwise, in the child interface, we cannot define any new abstract method. Otherwise, child interface wouldn't be a functional interface. And if we are trying to use a functional interface annotation, then compilers use as error message, as we have already seen in here. Okay, so this is the concept of functional interfaces and a lambda expression. In the So we can see in a parent class and a child interfaces, we can write any number of default methods and static methods. There are no restrictions, but only the restriction is the abstract method. Only should be the one abstract method. Okay. So functional interfaces versus a lambda expression. Another concept, functional interface with respect to lambda expression. Once we write a lambda expression to invoke its functionality, then functional interfaces is required. We can use functional interface reference to refer a lambda expression. So lambda expression, it is like it is a anonymous function, nameless function. So for those purpose we are using to implement the logic of this a functional interface, abstract method logic. For that purpose we use a lambda expression. So we can use a functional interface reference to refer a lambda expression. Whenever functional interface concept is applicable, there we can use a lambda expression. Okay. Example, without, if we are seeing without lambda expression. So in here I am seeing, I am giving into this example only. I am removing all these things. Okay. Inter, interrupt, interrupt. Okay. In here is only one method, public void method 1 without yeah. So functional interface with respect to the lambda expression. So once we write a lambda expression to invoke its functionality, then a functional interface it is required. We can use a functional interface reference to refer a lambda expression. So wherever functional interface concept is applicable, there we can use a lambda expression. So for calling, for implementing logic for the functional interface, we are writing logic into the to a lambda expression. Okay. So without lambda expression, I am going to write a program. I have taken one interface into one method. Sorry, method one. Now you have taken one class, that is implement this method in interrupt and a method one. Now for calling this class, I have taken public class test. In here is main method. Okay. In here we are calling interrupt I is equals to I am creating this class object new demo. Then I am calling I dot method one. So this is without using a lambda expression. What is this error? Interest is already used, already defined. Where I have defined? So okay, that is in here it was defined, so it was giving error. So I am running this one. I can give as the test because public class should be safe. Demo control control new test. Yeah, now I can run Java application. Okay, so method one executed. So it is a without lambda expression. What happened? I defined one interface into one abstract method, then one class. We have implemented this method, and then we have taken another class. Then there is main method class, and we just created an object, the object of this class, and we are storing its object onto the reference variable type like their interface type. So it is in here is auto boxing and unboxing concept. So now we are calling this interface reference variable to this method. So this method is executed. But this is like for writing a, now you will see with lambda expression. So with lambda expression. Now you will see how much reduced, how much short code we are writing. So here is only interface is already there. Okay. There is one abstract method. We have seen interrupt public void method one. How can we are writing into the with the lambda expression? We have writing a class. Now I am commenting this code. Okay, with lambda expression, I am writing class public class demo. Okay, into here main method. Into here we are going to write the functional lambda expression for this functional interface. It is a functional interface. I just define a functional interface. So we are going to write a lambda expression for this functional interface. So what is this? We are just we are going to the implementation logic. So we are just writing what we are going to writing. So method one executed. Okay. And this is what is the return type of this one? It is a interrupt. Okay. So now no need of this one statement. Okay. Now we can execute this one and we see method one executed. So before without using a lambda expression, how many lines of code we can see? These many lines of code. But after using a lambda expression for this interface, how many lines it is? Only one line we can say. So this is the speciality of the lambda expression. Okay. So if you want, I can show you one more example onto this one. Or you have much more confidence onto this one. I think you have much more confidence. In tomorrow lesson, we will implement one more logic with lambda expression and without lambda expression. We have go through the some of the examples. Okay, thank you very much. Let's explore much more onto the next session on